Welcome to the next lesson in the course, which focuses on part 2 of our coverage of key concurrency and scheduler operators in the Project Reactor Mono class. In this particular case, we're going to talk about the Schedulers.parallel factor method. This particular method arranges to run other operators in the designated thread pool that's returned from the parallel factor method. The Schedulers parallel factor method hosts a fixed pool of single-threaded executor service-based workers that are suitable for parallel work. In other words, being able to run multiple threads and be able to run operations in multiple threads that are mapped to multiple cores. Here's a simple example that illustrates how this method can be used in practice. This method is used in the context of something called multiply async. We'll talk more about multiply async when we talk about the case study that's associated with this lesson. This particular method is going to use the from callable factor method in order to multiply two big fractions. And it's going to use the subscribe on method in order to be able to arrange to multiply those big fractions in a thread in the parallel thread pool. And what happens here is it's going to create a mono that will emit the results of multiplying big fraction 1 and big fraction 2 in a thread from that parallel thread pool. Notice how convenient and declarative this approach is. You don't have to worry about creating threads. You don't have to worry about stopping threads. The threads are going to be created ahead of time in a thread pool, so the creation cost will be amortized. The parallel method is optimized for fast-running, non-blocking operations. These operations are typically compute-intensive, not blocking I/O intensive. There are other ways of having other kinds of pools that are more designed for use with blocking I/O, and we'll talk about them later. As with some of the earlier discussions we've had about the schedulers factor methods, like the single factor method, the parallel factor method creates threads that are implemented as so-called daemon threads. And what that means, of course, is that these threads will automatically be shut down when all the other non-daemon threads go away. Even if the daemon threads are doing some background work, their lifetime is essentially pegged or limited to the lifetime of the non-daemon threads. You can read more about daemon and non-daemon threads at the link in the slide below. RxJava has a factor method in its schedulers utility class called computation that's very similar to the parallel factor method we have here with Project Reactor. So similar capabilities, but for some interesting reason, they chose to give them different names in the respective schedulers utility class.